Greetings from EPG Pathshala. Today in this module we are going to talk about modes of operation. Up till now what we have learnt is to use symmetric algorithm. Symmetric algorithms are block ciphers. The input is divided into certain blocks of data and the operations are performed on it. So, input usually in DES algorithm was 64-bit. The question here is, if the input is very large, then how would you perform operations on this large data? So, the solution is to use different modes of operation. Today we will check which are the modes of operation and how do they work. To start with, there are 5 types of different modes of operation, and the purpose is already clear that for any encryption of the message, length is more than 64 bits, break the input into the blocks of 64 bits and apply the apply ciphers or apply 5 modes of operation. You can apply any one of them, no need to apply all 5 operations. They are to list with electronic code book, cipher block chaining, k-bit cipher feedback mode, k-bit output feedback mode and counter mode. The first we are going to discuss about electronic code book. Both the things need to be discussed, encryption as well as decryption. How does encryption work in electronic code book? So, your plain text, key has to be input, plain text and key would be encrypted and ciphertext would be generated for each block. So, the vision is clear. Our input has been divided into n blocks of size of 64-bit. Each block would be given a key and output would be generated with this. The decryption is exactly the reverse of encryption. What you have to feed to the decryption module is the ciphertext which you have generated, the same key which you used for the encryption, the output would be the plain text that has been generated. The idea is clear, but still to have a bulleted list how electronic code book works, they divide your input into the 64-bit block. If a block is not of length 64-bit, do a padding so that you can get a length of 64 bits. Encrypt each block with a secret key, and as you have observed, the decryption is exactly the reverse side of the encryption process and you can get the original text back. What problems you can identify in electronic code book? If the 2 blocks are identical, so to give you an example, if the first block, though our length is of 64-bit, for your understanding I would take a length of 6 bits. Now, what are we doing? We are applying the encryption operation with the same key and then we will get a ciphertext. Now, once again the same, we are taking the second block. If that block also has the same plain text, we are applying the same key. So, C2 would be generated, but since P1 is equal to P2, key remains the same for both this. So, C1 would be equal to C2. Now, the question is which encryption algorithm you can apply. You can apply any algorithm saying DES, AES, any symmetric algorithm you can apply for the encryption. So, what you observe that if the plain text remains the same, the ciphertext we get would be the same. If analysts find out that which are the repetitive elements in the plain text, and it gets repeated after how many periods or how many multiple of bits, then it can use the substitution or rearrangement of the block. So, just to put my point back, what happens that if there is some block in between, this is P1, this is P2, this is P3. Now, P1 and P3 are the same. So, what he can do is P3 can be replaced at P1 place and P1 can be replaced at P3 place. So, what an analyst can do, he can find out which are the blocks, he can do substitution or rearrangement. Now, second, another problem with electronic code book is, suppose a company is maintaining a list of database having the employee name, his account number and his salary. Now, what is the problem here? Each line is 64 bit long, that is very clear because we are going to work on modes of operation on 64 bit. Now, salary field is divided into the 1000 and 10,000 positions. So, one thing is clear ki identical salary would produce the identical ciphertext. So, if two ciphertexts are same, the analyst can find out that these two employees have the same salary. Another problem is, since there is a distinguish between 1000 and 10,000 position, analyst can copy the 10,000 position into the position of a employee who does not have a salary into the 10,000 field. To explain you my point, what we can see is, suppose employee Roger has a salary that is 52,000. Now, we all know there is a distinguish between this and this. Salary field is divided into these two blocks. Now, there is a person called clerk who has a salary only this. So, now analyst knows that at which point the 1000 position and 10,000 positions differs. So, he can copy this 10,000 position ciphertext directly into the clerk's salary field. So, clerk's salary field would be increased by 52,000. So, this is a problem with electronic code book. So, now what is the solution? The one solution is use the randomized electronic code book. In the randomized code book, what we can see is there is a plain text block which is exclusive OR with a random number, and then it is given to the encryption block and ciphertext is generated. The same way for the block M2, generate another block of random numbers, do the exclusive OR, and the output should be encrypted to get a C2. What we introduced here is a random block of R1 and R2. So, even though the M1 is equal to M2, the randomized block would generate a new plain text out of M1 and M2 which is not same. So, this is the idea behind randomized code block. Idea is clear that we have to generate random number every time. So, in a decryption process, that same random number should be used. So, now what is the problem here? In earlier block we had to pass only C1 and C2. Now, in this case what we have to pass? We have to pass C1 as well as R1, C2 as well as R2. This is in electronic code book, this is in randomized electronic code book. So, we instead of only ciphertext, we have to pass the corresponding random bit block. So, the bandwidth utilization would be doubled. So, what advantage we achieved? We achieved the advantage that even though there is a two same plain text, their ciphertext would be different, but what overhead we achieved? We achieved the overhead in terms of we have to send the double amount of data. So, attacker can rearrange the blocks, it can do R1 and R2 and it can change the but still he can have a predictable effect. So, now there is a third type of modes of operation, that is called cipher block chaining. How does this work? So, time is equal to 1, 2 and n. In the what you can get from the name is, this is a chaining of whom? Cipher block. So, C1 is fed as an input to the second block, the so on. So, in the last block what you can see is Cn minus 1, the cipher text of the previous block would be fed. But what about for the first block? Since there is no previous block, we are going to use one random number block which is called IV. IV stands for initialization vector. What you can observe is, there is P1, there is initialization vector which would be exclusive OR. The output would be encrypted with the help of a key and C1 would be generated. This C1 as you can see is an input to the next block. P2 would be exclusive OR with a C1. We will get an encryption and then K would be fed and C2 would be generated. Idea, as I mentioned, whenever we want to encrypt any block, we are randomizing that block with the cipher text of the previous block. Is it secure? So, before analyzing whether this kind of block of mode of operation is secure or not, I would like to point out on the decryption part, how the decryption would be worked. So, C1 would be fed as an input, key would be given, the decryption process would generate the output of the output of the decryption process, which would be exclusive OR with an initialization vector, and we will get our plain text 1 back. The same way, in the last block what would happen? Cn would be fed in the decryption block, K would be again inputted, whatever may be the output, it would be exclusive OR with a cipher text of the previous block to get the plain text for the nth block. This is how decryption works. So, idea is, it says it is clear that it takes the previous block cipher text and uses that as a random number input and exclusive OR with the next plain text. Now, initialization vector, we have a question about initialization vector. What happens if IV is not used at all or it is set to 0? So, for repeated message, same cipher text would be generated. To put the point, we will again look back, what if there is no, suppose our plain text is, if there is no IV or it is S0, you all know how exclusive OR operation works. Exclusive OR works like 1, if it is 1 and 0 it is 1, for 0 and 0 it is 0, 1 if the inputs are same, the same 0 output is generated, if the input are different the output is 1. So, what you can say, if my initialization vector is either 0 or it is not at all there, the P1 is repeated. So, there is no randomization generated. Since no randomization generated, for the same plain text there would be the same cipher text generated. So, there has to be a role of IV. IV should neither be omitted nor it should be all zeros. Now, the question is, what if Cn is changed? You all have observed from the figure that if Cn is changed, or as we can say C2 is changed, there is some change in C2, or to visualize it more, if there is any change in C1, C1 is fed as an input to exclusive OR with P2. So, any change in C1 would change a particular bit of P2, fine. So, C1 generated is 1010 and in the middle somebody changes it to So, which bits would be affected for P2? The bits which have been changed. So, if there is a change in 2 bits, the cumulative effect in the P2 would be in the 2 bits. So, this is what I am trying to convey here, कि if Cn is changed, it would change the decrypted Cn plus 1 to yield Mn plus 1. Changing in third bit of Cn will change third bit of Mn plus 1. Cn is always decrypted with an exclusive OR with Cn minus 1 to get Mn. Now, what is the solution to this problem? You have to attach CRC. CRC is nothing but a cyclic redundancy check. If there is any change in the bits, the cyclic redundancy check would not be the same as it was sent by the sender, and receiver can identify which bits are in error. Now, what are the problems with CBC? That as we have seen, this is a cipher block chaining. The previous block ciphertext is an input to the current block of ciphertext. So, if we want to construct CI or MI to destroy data, attacker can take any building block and construct corresponding plain text. He would generate a message that is garbled. If when the garbling would be helpful, if the whole salary field has been changed. So, for the check into the salary field, generate 64-bit CRC. So, we have problems with CBC cipher block chaining as well. So, next is output feedback mode. Output feedback mode says, how would you work around it? So, there is an initialization vector. Initialization vector is an input to the shift register. So, that would be divided into B minus S and S bits. So, the shifting is performed by S bits. The 64-bit output would be encrypted with the help of the key. Again, if input is 64-bit, the output would be of 64-bit. In this case, for output feedback mode, the first S bits are taken. From the plain text also S bits are taken, they are exclusive OR to generate the cipher block. C1 would be generated. Now, what happens in this case? Output of the encryption, you get S bits and discarded B minus S bits. These S bits are again forwarded to the next stage. For example, suppose we have 8-bit register, out of that we take S is equal to 4. So, only 4 bits would be exclusive OR with a 4 bits of plain text. The rest of the 4 bits would be discarded. Now, this S is what we said is it is again given to the next stage. What happens here? There is something in the register, so it has to be shifted by S bit to make a position for the previous S bits which have been propagated here. Once again the same process would be followed. 64-bit block would be encrypted with a key. We will generate the 64-bit. Out of that 64-bit S bits would be used and rest of the bits would be discarded. The process is same. Take S bits of the P2 block, exclusive OR to generate C2. You can see it is repeated for n blocks to get the ciphertext for the nth block. How the decryption process would work? So, for the decryption process to work, what we have to do is once again the same process would be repeated. This time you can see the output of S bits and what is the input? Input is again a C1, S bits of C1. So, P1 would be generated. So, only difference is in this module. In the encryption module, P1 was fed, it was exclusive OR with the S bits and C1 was generated. In decryption process, C1 is input with the S bits of the key and P1 would be generated. Now, what is the advantage of disadvantage of the output feedback mode? The first thing, output feedback mode is a stream cipher. We have seen the distinction between block cipher and stream cipher. Block cipher says you have to input 64 bit at a time and output would be the 64 bit at a time. In a stream cipher, what happens, we feed 64 bits, the processing would be done bit by bit and output would be bit by bit. That means the first bit would be output, then the second bit, then the third bit, not the whole block would be the output at the same time. IV, what we say, is a one time pad which we have generated. If you have the figure in mind, we are using 64 bit register. So, it is nothing but the generated 64 bit for the one time use. Now, what you can observe here is the calculation is predefined. So, in this you can see this is a B bit register. So, we can say we can always generate B0, that is 64 bit random number. Once again encrypt B0 to get B1, encrypt B1 to get B2. So, we will get B0, B1, B2. Now, whatever the size of input is, take as many bits out of the B0, B1 and B2 and exclusive OR with them. The encrypted message is then transmitted along with IP to the receiver and receiver computes the same one time pad. Just to focus on this, what we are trying to say that initialization vector would be communicated between sender and receiver. Out of that, the sender would be generating B0, B1 and B2. The same way receiver would also be generating B0, B1, B2. So, what a sender and receiver has to have a common in them, the key which they are using for the generating B0, B1, B2 and the algorithm which they are using for generating B0, B1, B2, they should be pre-communicated. The advantage of this is this can be generated in advance. It does not depend on the what input the user is giving. So, we can generate IV B0, B1, B2 in advance. Now, the idea here is if some of the bits of the ciphertext is garbled, only those bits in the plain text get garbled. Now, to put my point here, I would go back to my slide saying that what happens here, if you have observed, suppose I have 8 bit input, out of that only 4 bits are used, or we can say the first 4 bits are used. So, this would be given back to the next stage. So, if there is any error in this, what would happen? It would be shifted for the 4th S bits time. So, when the next 4 bit comes, once again it would get shifted. So, if you remember the step, what happens, it says you have to shift it to S bits to make a position for this S bits. So, it would get shifted and 1 0 1 1 and these 4 bits would be appended here. So, this would keep on shifting. So, if there is any error in this bits, the next time it would be shifted by 4 bit and then the error would go away. So, the idea behind this cipher is if there is any error in these bits, they get shifted So, the erroneous input would be discarded at one point of time, they would not be cumulated with the next stages. If the plain text and the ciphertext are known by an adversary, XOR the plain text and ciphertext to get a key. What are the differences between OFB and CBC? Some of the bits are garbled, only those bits of the plain text are garbled in case of OFB. In case of CBC, what happens? If the CN is garbled, MN will be completely garbled and the some bits of the MN plus 1 will also get the garbled. In OFB, we can take the arbitrary size of message input. In CBC, what happens? Encryption cannot be done on a single byte. Either the user has to wait for the more number of inputs or it has to do a padding. Next is a cipher feedback mode. So, what you can in the OFB, what happened? We took this as a carry forward to the next stage. Now, since this is a cipher bit feedback mode, we are carry forwarding the S bits of the ciphertext. The whole process remains the same. The S bits would be propagated to the next stage. To make the position for this S bits, the previous data should be shifted by S bits. So, the S bits would take, the new S bits would take the position. They are now the 64 input would be given as an input to the encryption algorithm with the key. It would take the 64 bit, first S bits are used, rest are discarded. Those S bits would be exclusive OR with S bits of the plain text to get the ciphertext. Now, out of this ciphertext, once again S bits would be taken and they would be carried forward to the next stage. The decryption process is the reverse of the encryption process. CFB, once again, if we put the bulleted list how the CFB works, there are k bits at a time generated, they are exclusive OR with k bits of the plain text. K bit shifted are the k bits from the previous block. So, as you understood from my point, these are, if we consider this as a k bits from the theory, it says k bits added are the k bits shifted. A byte lost, 1 byte of the plain text is lost, next 8 bytes are garbled, then plain text will decrypt properly. If a byte added to ciphertext stream, garbage of 1 byte will change the next 8 bytes. The last mode of operation is counter mode. How does it work? It works on basis on the counter. There is a counter, counter plus 1 and counter plus. So, every time we have set a counter, for the next block we will increment the counter, up to the nth block we will keep on incrementing the counter. The counter would be input to the encryption block, the key would be input, whatever the output is we will exclusive OR with the plain text to get the ciphertext. The same process would be repeated for all the blocks. If we have to visualize how the decryption would work, so decryption would again be the same thing, counter would be given to the k, once again the encryption would be applied, whatever may be the output, it would be exclusive OR with C1 to get the P1. Same way counter plus 1, it would be encrypted with the help of k, exclusive OR with C2 to get P2. Counter is nothing but a one time pad which we have generated. We can call it an initialization vector. Initialization vector has been incremented by 1 to get the successive block of one time pad. So, this is all about modes of operation. We have seen how different modes of operations work, what are the advantages and what are the disadvantages, and how you can proceed to get the length of the message which is greater than 64 to be encrypted. Thank you. Thank you. Thank you.